Hello Velociraptors and welcome to my classroom. So we've covered out the first basics of stoichiometric calculations. We've talked about theoretical and actual yield. The last topic that we need to talk about is something known as limiting in excess. So in all the previous problems, we've said, let's just assume we have infinite enough of the other product that we're trying to calculate, meaning that it's going to react completely. We're not assuming that there's any other limitation on the reaction. However, in real life, this isn't true. There's normally a limitation on the reaction, and we need to see how that works. And of course, in order to do that, we're going to bring back those same good old Oreos. So let's take a look. Okay, I know we've got the Oreos back, but I'm going to show an assumption that we made in the first video about stoichiometry, the basics. Now, to reveal that assumption, we need to look at what we started with in the very beginning of the problem. So first, I created this equation associated with the Oreo. So 2 chocolate wafers plus a filling yields CW2F, 1 Oreo. And the very first question that I asked was, okay, well, how many Oreos can you make with 6 chocolate wafers? And we talked about, okay, well, if there's 2 wafers per Oreo, then that means I can make 3 Oreos. Now, this has an associated assumption with it. It assumes that you have enough filling to completely react all those wafers, or enough to make all those cookies. That is a big assumption. Now, all the problems up to this point have been making that assumption. So when you see the problems that say with excess or in excess, that's what it means. It's showing you that that doesn't matter because it's not going to limit the reaction. Now, for example, let's say I change the question. How many Oreos can you make with 6 chocolate wafers and 2 fillings? Well, immediately you would say, wait a minute, if I've only got 2 fillings, well, that can only make 2 Oreos. Yeah, the 6 wafers can make 3, but the fillings can only make 2. That is what we call a limiting reactant. And that is important as we move through stoichiometry because we don't always have enough. Now, sometimes we do have things in excess, but not always. So let's take a look at another example, or a real chemical reaction. So let's look at the synthesis of water. So here I have oxygen gas reacts with hydrogen gas to produce water. And I want to illustrate what I mean by limiting in excess. So here I have a bundle of oxygen gas here, kind of just floating around. And then here I've got another bundle of hydrogen gas floating around. Now, of course, they're not going to readily react. They need to have enough energy in order to react, but we're going to assume they're just going to automatically react. Always assumptions in chemistry and science in general. And in this case, I can see, well, every water molecule requires 1 oxygen and 2 hydrogens. So if I took an oxygen molecule right here and I reacted it with 1 hydrogen, well, that wouldn't work. I would need 1 oxygen molecule needs 2 hydrogen molecules. And when that happens, it produces 2 waters. 2 waters. Perfect, they're gone. So let's say we converted them to water. And we could do the same thing. So if I get 1 more, 2 more, okay, I rotate them away and I make 2 more water. Awesome. And I can do it again. I've got enough. I have 2 more, and I make 2 more water. Okay, now, can I make more water? No, I can't because the hydrogens have limited the reaction. There are no more. I have more oxygen left over. That's an excess reactant. But I have no more hydrogen in order to make the waters, which means the hydrogen was limiting. That's what we're talking about when we're talking about limiting in excess. The one that I limited the reaction, I used it up first, that is the limiting. The one that I have left over, that is the excess. Now, of course, this was relatively easily illustrated with molecules, but what if we did it using moles? So let's take a look at another example here. Let's look at the example reaction of the creation of ammonia. So ammonia is created by the reaction of nitrogen gas reacted with hydrogen gas to yield ammonia. And you can see I've already balanced this chemical reaction for you. 3, 2, that's 6 H's, 2, 3, that's 6 H's, 2 N's and 2 N's. Perfect, that looks great, it's balanced. Now, a lot of times what we might ask is, okay, well, given a certain amount of each reactant, so let's say I have 4.4 moles of H2, and I have 2.3 moles of N2. A question I might ask is, well, how much NH3 can I actually make? And you have to figure out first what the limiting reactant is. So which one of them is going to be used up first? And in order to figure that out, you can do it a few different ways. But normally what I like to do is I would calculate the moles of product that each would produce. So if I had 4.4 moles of H2, well, 4.4 moles of H2, and I set out some train tracks. So 4.4 moles of H2, I know that I want ammonia, I have hydrogen gas, so that's 2 over 3, just like I did in the stoichiometric calculations. And I would get, okay, well, that's 2.9 moles of ammonia. Perfect. Now I might do the same thing for N2. N2 is 2.3 moles of N2. I want ammonia, 2 over 1, so it would be 2.3 times 2. And I would get that it is 4.6 moles of ammonia. Now quickly here, I can see I have very drastic different amounts, 2.9 moles and 4.6 moles. I need to figure out which one's limiting and which one is excess. Well, I can only make the least amount. So this one is going to be used up first, which is why it is limiting the reaction. It's only going to allow the reaction to produce 2.9 moles of ammonia, where this one would allow the reaction to produce 4.6 moles of ammonia. So whichever one produces the least amount of product is the limiting reactant. The other one is the excess. So in this case, H2 is limiting, N2 is excess. That is limiting and excess. Excellent work, Velociraptor. Now you are a master of stoichiometric calculation. You understand how to convert between mole to mole, mass to mass using molar ratios. You know what theoretical and actual yield is. You know how to calculate percent yield. And now you understand limiting and excess. Great work. Definitely challenge yourself by looking at the other practice problems contained in this section, because we didn't touch on a lot of the other calculations that can be performed with these problems. So if you're thinking about going past pre-AP chemistry to AP chemistry or organic chemistry, definitely check out some of the problems, and your instructor is more than happy to help work through any of them. Thanks for tuning in.